What if everything you think is real isn't? What if the chair you're sitting on, the screen you're staring at, even your own thoughts, are nothing more than mathematical abstractions playing out in a cosmic computer we call the universe? Stephen Hawking didn't just solve equations about black holes and the Big Bang. He dared to ask the question that makes most physicists deeply uncomfortable. What is reality, actually? And his answer will shatter everything you thought you understood about existence itself. Before we dive into this mind-bending revelation that physics desperately tries to avoid, smash that subscribe button right now. Because what you're about to discover isn't just science. It's a complete paradigm shift in how you perceive every single moment of your life. Trust me, you've never heard reality explained like this before. Let me start with something that probably seems obvious to you. You're real, right? You exist. The world around you exists. There's a physical reality out there, independent of whether you're observing it or not. This seems so self-evident that questioning it feels almost absurd. But here's where Stephen Hawking threw a grenade into the comfortable assumptions of physics. He argued that this obvious truth might be completely wrong, not just philosophically debatable, but scientifically questionable based on the mathematics that govern our universe. Most physicists, when they do their work, operate under what's called realism. They assume there's an objective reality that exists independently of observation, and their job is to discover the laws governing that reality. It's a clean, comfortable framework. You measure things, you find patterns, you write equations, and those equations describe something real out there in the world. Even quantum mechanics, which gets weird, is usually taught with the implicit assumption that there's still something real happening. We just can't access all the information about it. Hawking rejected this completely, and he did so not out of philosophical preference, but because the mathematics of quantum mechanics and cosmology forced him to. This is what makes his position so radical and so difficult for many physicists to accept. He wasn't playing philosophical games. He was following the math to its logical conclusion, and that conclusion is deeply, profoundly strange. Before we go deeper, I'm curious, where are you watching this from right now? Drop your location in the comments below. I want to know where in the world people are having their conception of reality challenged. Are you in London? Mumbai? Mexico City? Let me know, because what we're about to explore transcends geography. It questions the very fabric of what we call place. The framework Hawking championed is called model-dependent realism, and it's one of the most radical philosophical positions ever taken by a mainstream physicist. Here's the core idea. There is no theory-independent concept of reality. We can't talk about what's really there, independent of the models we use to describe it. Different mathematical models can describe the same phenomena equally well, and asking which one represents true reality is a meaningless question. This sounds abstract, so let me give you Hawking's favorite example. Imagine you're watching goldfish swimming in a curved fishbowl. From your perspective outside the bowl, the fish move in nice, predictable arcs. But imagine you're a tiny scientist living inside the fishbowl. From your perspective, you'd see the fish moving in completely different paths because of the distortion of the curved glass. You'd develop different laws of physics to describe their motion. Now, here's the question. Which description is real? The view from outside or inside the bowl? Hawking's answer, both. Or more precisely, Neither is more real than the other. They're different models describing the same phenomena from different reference frames. What matters is whether a model successfully predicts observations, not whether it corresponds to some ultimate reality. And here's the kicker: we're all inside our own fishbowl. We're trapped inside a universe, observing it from within, using models that work but may not represent any underlying reality. This isn't just philosophical wordplay. Hawking applied this framework to solve real problems in physics, particularly in cosmology and quantum mechanics. Take the question of what happened before the Big Bang. Most physicists tie themselves in knots trying to answer this because our intuition demands that something must have come before. But Hawking, using model-dependent realism, could simply say, in some models, the question is meaningless because time itself begins at the Big Bang. There is no before. The question only makes sense in models where time is eternal, and those models may not be the most useful for describing our universe. This approach freed Hawking to explore possibilities that others avoided because they seemed to violate our intuitions about reality. His no-boundary proposal with James Hartle describes the origin of the universe using imaginary time, a mathematical concept where time behaves like a spatial dimension near the Big Bang. Is imaginary time real? That's the wrong question, according to Hawking. The right question is, does this model make accurate predictions? And it does, or at least it's consistent with observations. What makes this so uncomfortable for many physicists is that it seems to undermine the entire enterprise of science. If we're not discovering objective truth about reality, what are we doing? Just playing with mathematical models? Hawking would say yes, but that's not a diminishment of science. It's a more honest description of what science has always done. We create models that work, that predict observations, that unify disparate phenomena. Whether those models reflect some ultimate reality is unknowable and, more importantly, irrelevant. Here's where it gets even stranger. In quantum mechanics, the act of observation affects what you observe. The famous double-slit experiment shows that particles behave differently when measured versus when not measured. Most physicists treat this as a weird feature of quantum mechanics, but still assume there's something real going on at the quantum level. We just can't access complete information about it. Hawking went further. He suggested that the universe literally doesn't have definite properties until they're observed and calculated within a particular model. Think about what this means. Right now, you're observing the world around you. Your brain is creating a model of reality based on sensory input. According to Hawking's framework, that model is reality for you. There's no separate real world that your model approximates. The model is all there is. Different observers, using different sensory systems or different conceptual frameworks, would construct different models, and none would be more correct than others, only more or less useful for predicting observations. This sounds like solipsism, the idea that only your own mind is sure to exist, but it's subtly different. Hawking isn't saying other people or objects don't exist. He's saying that existence itself is model-dependent. An electron exists in quantum mechanical models. A chair exists in classical mechanical models. But asking whether the electron or chair exist in some model-independent sense is asking a question that has no answer. I want to pause here and get your reaction. Does this idea that reality itself might be model-dependent, that there's no objective truth independent of observation and theory. Does this resonate with you, or does it feel fundamentally wrong? Drop a comment right now, because we're about to go even deeper, and I'm genuinely curious how people initially react to this framework before seeing its full implications. One of the most powerful applications of Hawking's approach is to the measurement problem in quantum mechanics. The traditional interpretation says that quantum systems exist in superposition, multiple states simultaneously, until measured. The measurement collapses the superposition into one definite state, but this raises uncomfortable questions. What counts as a measurement? Does it require a conscious observer? Where exactly does the collapse happen? Hawking, along with colleagues like Leonard Mlodinow, argued that these questions arise from trying to impose a model-independent reality on quantum mechanics. In the model-dependent framework, there's no collapse because there was never a definite reality to begin with. When you measure a quantum system, you're not discovering a pre-existing property. You're forcing the system to manifest a property within your observational framework. Different measurements would extract different properties, and none is more real than others. This has profound implications for cosmology. When we observe the cosmic microwave background radiation, the afterglow of the Big Bang, we're seeing the universe as it was about 380,000 years after the beginning. We use these observations to construct models of cosmic history. But according to Hawking, that history doesn't exist independently of our observations and models. The past is created by the present, not the other way around. This is what Hawking called top-down cosmology. Instead of imagining that the universe has a definite history stretching back to the Big Bang, he proposed that the present state of the universe selects from among all possible histories. The past is not fixed until it's observed and incorporated into a model. The universe's history is, in a sense, written backward from the present. I know this sounds crazy. It violated Hawking's own intuitions when he first encountered it in the mathematics. But he was intellectually honest enough to follow where the equations led. And they led to a universe far stranger than the one we naively assume we inhabit. A universe where the past is not fixed, where reality itself is observer-dependent, where the fundamental question, what really happened, has no determinate answer. Let me give you a concrete example of how this plays out. Consider the question, did the universe start with the Big Bang, or has it existed eternally? In standard cosmology, this is a factual question with a definite answer. We look at evidence, cosmic expansion, background radiation, and conclude the Big Bang happened about 8 billion years ago. But in Hawking's framework, both models can be valid. In one model, using certain mathematical descriptions, the universe has a beginning. In another model, using different mathematics like imaginary time, the universe is eternal and has no boundary. Both models fit the observations. Asking which is really true is meaningless. They're different, but equally valid descriptions. This is why mainstream physics often avoids Hawking's full philosophical position. It's deeply uncomfortable. Scientists want to believe they're discovering truth, not just constructing useful fictions. The idea that there might be multiple, incompatible, but equally valid descriptions of reality challenges the fundamental motivation many people have for doing science. But Hawking embraced this discomfort. He argued that model-dependent realism is actually liberating. It frees us from the futile search for ultimate truth and allows us to focus on what science can actually deliver: increasingly accurate and comprehensive models that predict observations. Whether those models reflect some transcendent reality is a question we can safely ignore. There's a deep connection here to something Hawking spent much of his career working on: the nature of information in physics. When matter falls into a black hole, what happens to the information about that matter? This seems like an esoteric question, but it goes to the heart of what we mean by reality. If information is destroyed, then the past can't fully determine the future, which violates fundamental principles of physics. If information is preserved, it must be encoded somehow on the black hole's event horizon, or in the Hawking radiation emitted as the black hole evaporates. Hawking initially thought information was destroyed, which would have radical implications for the nature of reality. It would mean the universe is fundamentally non-deterministic, that the past doesn't contain all the information needed to specify the future. Later, he changed his mind and concluded that information is preserved, but scrambled in ways that make it practically impossible to decode. This fits with model-dependent realism. The information exists in some models, doesn't exist in others, and asking which model is really true is the wrong question. What's your gut feeling about this? Do you find it unsatisfying that we might never access ultimate truth about reality? Or is there something appealing about the humility of acknowledging the limits of what we can know? I'm genuinely curious because I think people's reactions to this reveal deep assumptions about knowledge, truth, and reality. Let me know in the comments. Another area where Hawking's approach shines is in understanding the role of consciousness in physics. Many interpretations of quantum mechanics give consciousness a special role, suggesting that conscious observation is what collapses quantum superpositions into definite states. This leads to all sorts of mystical speculation about consciousness creating reality. Hawking would have none of it. In his framework, consciousness is just another physical system, another way of processing information and creating models. It's not special or fundamental. This doesn't mean consciousness is unimportant. Obviously, from our perspective, it's the most important thing because it's the only access we have to any models or observations. But it's not metaphysically privileged. A computer running a complex simulation is, in principle, doing the same thing your conscious mind does, processing information according to rules and generating a model of its environment. Whether that computer is conscious in the sense we are is interesting, but not fundamental to physics. This materialist stance was consistent throughout Hawking's work. He saw no need to invoke anything beyond physical law to explain observations, including observations about consciousness, free will, or meaning. Everything, absolutely everything, can in principle be described by mathematical models of physical processes. This doesn't make life meaningless or robotic. It just means that meaning, consciousness, and agency emerge from physical processes rather than existing independently of them. Here's where Hawking parts ways with both traditional religion and traditional science. Religion typically posits a reality beyond the physical, a spiritual realm not accessible to scientific investigation. Traditional science typically posits a physical reality that exists objectively and independently. Hawking rejected both. He saw no evidence for non-physical reality, But he also didn't think physical reality exists independently of models and observations. It's a middle path that satisfies neither the religious nor the naive realist. Yet Hawking found this framework deeply satisfying, even beautiful. He spent his career trying to find a unified model that could describe all physical phenomena, what physicists call a theory of everything. But unlike some physicists who think such a theory would reveal ultimate truth about reality, Hawking saw it as the most comprehensive and elegant model possible, not a description of transcendent reality, but the best tool we could hope for to predict observations and unify our understanding. This pragmatic approach to truth has precedence in philosophy, particularly in pragmatism and instrumentalism, schools of thought that judge ideas by their usefulness rather than their correspondence to reality. But what's remarkable about Hawking is that he arrived at these positions not through philosophical reasoning, but through doing physics. The math pushed him there. Quantum mechanics and general relativity, when taken seriously and pushed to their limits, seem to demand model-dependent realism. Let me give you another example that Hawking loved to use. Einstein's general relativity describes gravity as the curvature of space-time. Massive objects bend space-time, and other objects move along the curved paths. This is a beautiful geometric picture, and it makes incredibly accurate predictions. But is space-time really curved? Or is that just a mathematical convenience? And really, there's some force pulling objects together. Newton would have said the latter. Einstein might have insisted on the former. Hawking would say the question is meaningless. Both descriptions can work. Use whichever generates better predictions or is more mathematically elegant for the problem at hand. This flexibility is powerful. It allows physicists to use different formulations of the same theory depending on what's convenient. Quantum mechanics can be formulated using waves, particles, matrices, path integrals, or many other mathematical frameworks. They're all equivalent in terms of predictions, but suggest very different ontologies, different pictures of what's really happening. Model-dependent realism says they're all equally valid, and insisting one is truer than the others is missing the point. Where are you watching from, by the way? I asked earlier, but I'd love to get more responses. Drop your location in the comments. This conversation about the nature of reality is happening globally, and I'm curious how it resonates across different cultures and educational backgrounds. Are you a physics student? A curious layperson? Someone with a philosophical bent? Let me know. Now, here's where I want to share my personal opinion on this, and I really want your feedback. I think Hawking's model-dependent realism is not only correct, but actually comforting. Here's why. If reality is model-dependent, then the universe doesn't have some fixed, cold mathematical structure independent of observers. Reality is participatory. We're not passive observers of a pre-existing world. We're active participants in creating the world through our observations and models. This gives human consciousness and human science a central role in the cosmos, not in some mystical sense, but in the literal sense that reality as we know it depends on minds capable of constructing models. What do you think? Does this perspective make the universe feel more alive and participatory, or does it make everything feel arbitrary and unmoored from objective truth? I genuinely want to hear your thoughts in the comments because this is one of those deep questions where intelligent people can reasonably disagree. And the discussion itself is valuable, regardless of who's right. Let me continue by exploring the implications for free will, another topic where Hawking's views were characteristically bold and uncomfortable. If the universe operates according to deterministic laws, and our brains are physical systems subject to those laws, then in what sense do we have free will? Traditional physics avoids this question or gives unsatisfying answers. Hawking confronted it directly. His answer, free will, is an effective theory that works at the human level. We can't practically predict human behavior from fundamental physics because the calculations are impossibly complex. So we construct models at a higher level, psychological and sociological models, that treat humans as autonomous agents making choices. These models work. They predict behavior reasonably well and allow us to navigate social reality. The fact that these models might not be ultimately true in some metaphysical sense is irrelevant. They're useful, and that's what matters. This is model-dependent realism applied to human agency. At one level of description, using the model of fundamental physics, you're a deterministic collection of particles obeying physical law. At another level, using psychological models, you're an agent with free will making choices. Both models are valid in their domains. Asking which is really true is asking the wrong question. Notice how this dissolves the free will debate. Philosophers have argued for centuries about whether free will is compatible with determinism. Hawking's answer is that compatibility is the wrong framework. Different models describe human behavior at different levels, and the question of free will only makes sense within certain models. It's a feature of our effective theories of human psychology, not a fundamental fact about the universe. This pragmatic approach extends to questions of meaning and value. If the universe is just particles following mathematical laws, where does meaning come from? Traditional materialism struggles with this. Hawking's answer, meaning is a feature of high-level models we use to describe human experience. It's as real as anything else in those models, which is to say it's real within the framework where the concept makes sense. You don't need to ground meaning in fundamental physics any more than you need to ground economics in particle physics. Different levels of description, different models, all valid in their domains. This is probably Hawking's most controversial position, more controversial even than his cosmology. Many people, including many scientists, feel that there must be some ultimate truth, some model-independent reality that our theories approximate. The idea that it's models all the way down, with no bedrock reality underneath, feels vertiginous, like free-falling through infinite regress. But Hawking would ask, why do you need that bedrock? What work does it do? If you can never access it, never test it, never compare your models to it, then positing its existence is metaphysical speculation, not science. Science is about creating models that work, that predict observations, that unify phenomena. We've been extraordinarily successful at this. Why isn't that enough? Here's a thought experiment Hawking enjoyed. Imagine we're living in a sophisticated computer simulation. Everything you experience, including your memories and your sense of self, is generated by some advanced computer running code. Now, is the real reality the computer and its code, or is it the simulated world you experience? Hawking's answer, both are real, but in different models. If you're asking questions about your experiences, the simulated world is the relevant model. If you're asking about the substrate running the simulation, the computer, is the relevant model. Neither is more fundamentally real than the other. This simulation hypothesis, while speculative, illustrates the core insight. Reality is what we interact with using our models. If we can never access the base reality, the computer running the simulation, then, for all practical and philosophical purposes, our simulated world is reality. This isn't defeatist or nihilistic. It's just recognizing the limits of what reality can meaningfully refer to. Hawking applied these ideas to the biggest questions in cosmology. Why does the universe exist rather than nothing? Why does it have the particular laws and constants it does? These are traditionally seen as the ultimate questions, the ones that might point to God or some transcendent explanation. Hawking's approach diffuses them. In some models, the universe is eternal, and the question of why it exists is meaningless. In others, it pops into existence from quantum fluctuations, requiring no external cause. Different models, different answers, and no way to determine which is really correct. His final book, The Grand Design, co-written with Leonard Mlodinow, laid out this philosophical framework explicitly. The title is somewhat ironic. There is no grand design in the sense of a blueprint or plan. There are multiple possible designs, multiple models that describe reality, and we choose among them based on usefulness and elegance, not on correspondence to some unknowable ultimate truth. This book caused controversy because Hawking stated bluntly that philosophy is dead, that philosophers have failed to keep up with modern physics, and that scientists are now the bearers of the torch of discovery about the nature of reality. This dismissal of philosophy angered many philosophers, who pointed out that Hawking was himself doing philosophy, just not acknowledging it. And they had a point. Model-dependent realism is a philosophical position, whether Hawking wanted to call it that or not. But I think what Hawking meant was that traditional philosophy, divorced from mathematics and empirical observation, has become sterile. The interesting philosophical questions now require deep engagement with physics, math, and cosmology. You can't productively think about the nature of time without understanding general relativity. You can't think about determinism without understanding quantum mechanics. Philosophy and physics have merged, and many professional philosophers haven't made the transition. Hawking himself was a hybrid, a physicist who wasn't afraid to tackle philosophical questions using the tools of physics. This made him unusual in both communities. Physicists thought he was too philosophical, too willing to speculate beyond what's empirically testable. Philosophers thought he was too dismissive of conceptual analysis and too focused on mathematical models. He existed in the productive tension between the disciplines. Let me ask you, do you think philosophy still has a role independent of science, or has science subsumed the questions philosophy used to address? This is a live debate in academic circles, and Hawking took a strong position. I'm curious where you stand. Comment below. One of the most beautiful applications of model-dependent realism is to the question of cosmic fine-tuning. The universe appears to be exquisitely tuned for life. If the fundamental constants were even slightly different, stars wouldn't form, atoms wouldn't be stable, and life as we know it couldn't exist. This has led some to argue for a designer, or to invoke the anthropic principle. We observe the universe to be life-permitting, Because if it weren't, we wouldn't be here to observe it. Hawking had a more elegant solution. In the model-dependent framework, we shouldn't ask why the universe has the properties it does. Instead, we recognize that we necessarily observe a universe compatible with our existence. Any observers anywhere will necessarily find themselves in a life-permitting universe, not because of design, but because observation requires observers. The question, why this universe rather than another, assumes a model-independent reality that we then discover. But if reality is model-dependent, constructed through observation, then of course we observe a reality compatible with observation. It's tautological. This doesn't invoke a multiverse or infinite parallel universes, though Hawking didn't rule those out. It's simpler. The universe we observe is constrained by the fact that we're observing it. Different observers with different physical requirements would necessarily observe different universes, different sets of laws and constants. None is more real than others. They're all equally valid models describing what those particular observers experience. This is deeply strange, but also deeply elegant. It dissolves the fine-tuning problem without requiring a designer or infinite parallel worlds. It's just a consequence of taking seriously the idea that reality is observer-dependent and model-dependent. Throughout his career, Hawking pushed physics to confront questions it would rather avoid. What is time? What is reality? What is information? What is existence? These questions make most physicists uncomfortable because they seem too philosophical, too removed from testable predictions. But Hawking showed they're intimately connected to the mathematics. You can't do cosmology without confronting the nature of time. You can't do quantum mechanics without confronting the nature of reality. You can't study black holes without confronting the nature of information. And his answer to all these questions was consistent. They're all model-dependent. Time is what our models measure with clocks. Reality is what our models describe. Information is what our models track. Existence is what appears in our models. None of these have meaning independent of the frameworks we use to describe them. This might sound like he's evading the questions, but he's not. He's showing that the questions as traditionally asked contain hidden assumptions that modern physics has undermined. The assumption of model-independent reality is one such hidden assumption. Once you give it up, the questions transform. They become more precise, more answerable, and often less mysterious than they seemed. Let me bring this full circle to where we started. You're watching this video right now. You exist. The world around you exists. Is that real? Hawking would say, in the models you're using to navigate your daily life, absolutely yes. Those models work. They predict your sensory experiences. They allow you to function. The chair you're sitting on is real, in the model of classical mechanics that describes everyday objects. Is it really real in some model-independent sense? That question has no answer and needs none. This doesn't make your life less meaningful or your experiences less valid. If anything, it makes them more interesting. You're not a passive observer of a pre-existing reality. You're an active participant in constructing reality through your observations and models. Your consciousness, far from being an insignificant byproduct of physical processes, is essential to the very existence of the reality you experience. Where are you watching from, by the way? I've asked a few times because I really want to build a global conversation here. Drop your location in the comments one more time if you haven't already. This message about the nature of reality transcends borders, and I'd love to see how it's landing across different parts of the world. Hawking's final years were spent trying to unify quantum mechanics and general relativity, seeking what he called my-theory, a mathematical framework that could describe all physical phenomena. He never completed this quest. We still don't have a confirmed theory of everything, but what Hawking understood, and what many physicists still resist, is that even if we achieve such a theory, it won't be a description of ultimate reality. It will be the most comprehensive and elegant model we've found, useful for predicting observations and unifying our understanding, but still just a model. This humility about what science can achieve is paradoxically paired with incredible ambition. Hawking wanted to understand the universe as completely as possible within the framework of model-dependent realism. He wanted the most powerful models, the most comprehensive theories, the most elegant mathematics. But he never claimed this would reveal transcendent truth. It would reveal truth within our models, which is the only kind of truth we can access. I think this is ultimately why physics avoids Hawking's full philosophical position. It requires giving up the comforting story that we're discovering objective reality. It requires embracing uncertainty at a fundamental level. It requires accepting that the ultimate questions may not have ultimate answers, only answers within particular frameworks. And for many people, including many scientists, that's a bitter pill to swallow. But Hawking swallowed it gladly because he followed the mathematics wherever it led, and the mathematics of quantum mechanics and cosmology led him to model-dependent realism. It wasn't a choice driven by philosophical preference. It was a conclusion forced by taking seriously the equations that describe our universe. So here we are, at the end of this exploration. What is reality? According to Stephen Hawking, it's whatever our best models say it is. And those models might be multiple, might be observer-dependent, might be impossible to unify into a single framework. That's okay. We don't need unity at the level of ultimate reality. We need unity at the level of predictions and mathematical elegance. And that's achievable. Your life, your experiences, your thoughts right now as you watch this video, they're all real in the models that matter for human existence. They're no less real for being model-dependent. If anything, they're more interesting, more participatory, more connected to the deep structure of the universe than naive realism would suggest. This is what Hawking dared to say that physics avoids. Reality is not independent of us. We don't discover it. We participate in creating it through our observations and models. This doesn't make us gods. It makes us integral parts of the universe coming to know itself. And that's a far more profound and beautiful vision than the idea that we're just passive observers of a cold, indifferent, pre-existing reality. Before you go, I want to make sure you're getting the most from this content. If this video changed how you think about reality, if it challenged your assumptions, or gave you a new perspective, hit that like button. If you want more content exploring the deepest questions where science meets philosophy, subscribe to the channel and turn on notifications. And please, share this video with someone who enjoys thinking about the big questions, because these ideas are too important to keep to yourself. Stephen Hawking gave us a gift, a new way of thinking about reality that's both scientifically rigorous and philosophically profound. It's uncomfortable. It challenges our deepest intuitions, but it's also liberating, elegant, and possibly true. Though true in this context is a model-dependent concept. The universe Hawking revealed is stranger, more participatory, and more interesting than the one we naively assume we inhabit. And that's the real message here. Reality isn't what you think it is. Not because you're wrong, but because what you think is itself part of reality. Your models, your observations, your consciousness, they're not separate from the universe. They're how the universe manifests at a particular scale to a particular kind of observer. You're not in the universe. You are the universe, locally aware of itself, creating models to understand itself, participating in the grand cosmic project of reality, coming to know its own nature. That's what Hawking understood that physics tries to avoid. And now you understand it too. The question is, what will you do with this knowledge? How will it change how you see yourself, your life, your place in the cosmos? That's for you to decide, using whatever models serve you best. And that decision, that agency, is as real as anything else. Which is to say, it's real in the ways that matter. Thank you for taking this journey with me into the heart of what reality actually is, according to one of the greatest minds in human history. Comment below with your thoughts. Subscribe for more content that challenges how you see everything. And remember, reality is not what it seems. It's not even what physics says it is. It's what the best models we can construct reveal it to be. And that's both humbling and empowering in equal measure.